Welcome to Mathematics Lecture Series. Physical meaning of derivative. What is physical meaning of derivative? It is lecture number 21 in Applied Calculus series. Before the start of lecture, I request you kindly subscribe the channel as you find more videos on mathematics topics. Average speed. When f of t measures the distance traveled at time. Average speed over these two times t1 to t2 is equal to distance traveled, which is equal to f of t2 minus f of t1. Ellipse times means t2 minus t1. So by this formula we can find the average of speed. Here a rock breaks loose from the top of a tall cliff. What is the average speed? During the first 2 seconds of fall, during the first second interval between second 1 and second 2. So we have to find these during the first 2 second and during in first second between second 1 and 2. Very simple. Yeah, this is formula y is equal to 16t square f of t. In the last 16th century, Galileo discovered that a solid object, if we dropped from rest initially not moving near the surface of the earth and allowed to fall freely, will fall a distance proportional to the square of the time it has been fallen. This type of motion is called free fall. It assumes negligible air resistance to slow the object down, and that gravity is the only force acting on the falling object. Y denotes the distance fallen in feet after t second, then Galileo's law is y is equal to 16t square f of t. By using this formula, this law, we solve the first question for the first 2 seconds, which is equal to delta y over delta t. Here delta y means t to 16, here t is equal to 2 square minus from initially 16 here t 1 is equal to 0 square. So 16 to 4 64 minus 64 delta t means t2 minus t1 2 minus 0 64 upon 2 is 32 foot per second. Question number B, in which we have to find the and from second to and for the first 1 minute. So it is equal to delta y over delta t. Delta y means delta here time 2 square minus 16 here t1, so 1 square 2 minus 1. So we will have 48 ft foot per second. Here another example, physical meaning of the derivative. A body moves horizontally and its position at time t seconds is of t cube minus 60 square plus 9t. Find the body's acceleration at time. You have to find the acceleration at time what time? When its velocity is 0. When velocity is 0, then finds body acceleration, and also find acceleration when t is equal to 0. So s of t cube minus 60 square plus, now taking the derivative of this d by dt, t cube minus 60 square plus 9t, so it becomes 3t square, t cube derivative 3t square minus 60 here 12t. What is derivative of 90 is a 90. Here d by dt means distance upon time, which is equal to velocity, and acceleration is equal to velocity upon time, change into velocity upon change into time, so it is equal to acceleration. So here d by dt, what is velocity? It is here we have 3t square minus 12t plus 9. Now taking the derivative, 3t square is 60 minus 12t is derivative, 12t derivative is minus 12. So this is acceleration, and we have to find the acceleration whenever velocity is 0. So here velocity is here 3t square minus 12t plus 9. So equating is equal to 0. Now solve this equation. We have taken the 3 common and divide both sides 3. We will have t square minus 4t plus 3 is equal to 0. Now t square minus t minus, here we by middle break term system, we will have minus t minus 3t plus 3 is equal to 0. So what's common in between these two? T, and rest is t minus 1. Here minus 3 is common, so rest is t minus, so t minus 1 is common factor, t minus 3 is another factor. Both are equal to 0, so we will have t is equal to 1 3. So at these times we will have to find the acceleration. Thus acceleration of the body at t1 is just this t1, applying that acceleration equation 6t minus 12. So 6 here, t replace with 1, so 6 1 minus 1 minus 6 feet per second is square. And similarly the acceleration of body at t is equal to 3. So in this equation, in acceleration, apply the time. So 6 here, t is equal to 3 minus 12, so 6 foot per second is square. Thank you.